Thanks for joining me back for the second video on anatomy of a supernova. Paper 2, tracing the structure around exploding stars. The second paper explores another key piece of this puzzle, the environment around exploding stars. Supernovae don't simply occur in empty space. They occur inside bubbles of gas shaped by the entire star's life history. The study examines how stellar explosions interact with circumstellar medium, the CSM, the gas and dust surrounding the star before it dies. It's a fossil record of a stellar evolution. Every massive star sheds material over time through stellar winds, eruptions, or binary interactions if it's in a binary system. This expelled material forms shells, clumps, and extended nebula. When the star explodes, the expanding debris interacts with these structures. The resulting signals include radio emissions, X-rays, changes in spectral lines, and unusual light curves. In effect, the supernova blast acts like a probe that reveals the star's past behavior. The importance of the time domain in astronomy. These studies rely heavily on modern sky surveys such as ZTF, ATLAS, and PAN-STARRS. These surveys repeatedly scan the entire sky and catch transient events early on. That means that astronomers can follow supernova from the moment they appear. Without these surveys, unusual events like multi-peak explosions might have gone unnoticed. The bigger picture, the final years of massive stars. Kind of to sum it up, both papers point toward the same emerging conclusion. Massive stars may undergo violent instability shortly before exploding. Be interesting to see if Betelgeuse does this, won't it? The idea is gaining traction in astrophysics. I've reported on various reports now about this, and I firmly believe that super red giant stars actually do go through a chaotic period before they explode. Not all. You can't put just a thing on everything. The universe has taught us that, but probably many do. Okay? Evidence includes there's a precursor outburst seen before some supernova, dense circumstellar shells around these stars, sudden mass loss episodes, and changing spectral classifications on the stars. Instead of quietly evolving toward collapse, stars may experience last-minute convulsions. What does that mean for you and me? For visual observers and imagers, these studies connect directly to objects we can actually observe. Okay, and we'll touch more on this and actually get into a timeline, but examples can include IC 443 in Gemini, Cassiopeia A in Cassiopeia, the Veil Nebula in Cygnus. Their complex filaments and shock structures formed when expanding debris collided with its surrounding gas. What these new papers show is that these structures likely started forming before the star ever exploded. So when you look at a supernova remnant, realize what you're looking at is the interaction of the explosion with that surrounding gas and stuff that was there, lighting it up, and it was probably put there far long by the star before the star exploded. The takeaway, the traditional picture of stellar death was fairly simple. Massive star runs out of fuel, core collapse, supernova explosion, remnant expands into space. But the reality appears it's actually a lot more complicated than that. Stars may experience violent instability, extreme mass loss, and complex circumstellar environments before the final blast. When the supernova shockwave plows into those structures, these explosions can brighten again, change spectral type, and produce unusual emission signatures. In short, a supernova just isn't the death of a star. It's a culmination of a long, chaotic final chapter. And that final chapter of the star is messy. That's exciting. The knowledge that we're gaining. It'll be interesting to see how much this applies to Betelgeuse and to other massive stars over time as we look to them to one day go supernova. The next one, we're going to talk about the timeline of the chaotic final years of a massive star. So come back and join me for part 3. Thanks for joining me. We'll catch you in a minute. Clear skies to you.